These aren't my speaker notes.
Oh my god.
They're, dude, come on, man.
Hey
Just give
guys,
away
can you please sign in? It's like, uh, thanks.
This hack night was Hello? Oh man, wow. That's loud. All right. Has everybody signed in? Everybody signing on to the shout key here, this link. We'd really appreciate it if you all did that because it helps us buy food for you all. So thank you in advance. Please. Yeah, please. Should I just, oh yeah. Sorry, my bad.
Okay, yeah, go on.
Oh, am I just going? All right.
What? We're just going to throw the plug in right now.
All right, guys. Thank you guys for coming to week 4 of Hack Nights. Today we're going to talk about Git. My name is Meg. I am one of the co-presidents of Women in Computing.
I'm Brandon. I'm the co-president of Spark.
I'm Chris. I'm in IEEE, the student branch at IEEE.
I'm Lily. I'm the co-president of Spark.
And a quick project opportunity for you guys. If any of you guys are interested in working for Mayfest Productions, which puts on Dillo Day every year, either as a web developer or as an app developer, go to dilloday.com and download the application, and it's due sometime soon. So maybe check that out soon. And you can look at like my really shitty code. It'll be fun.
Yeah. Right. Yeah, we are live streaming this event. You guys don't care, but on the Facebook event, the link is there. So for any of your friends that, might have missed this, go to the Facebook event and there should be a YouTube link there. Please raise your hand or yell at me if there's not.
Okay, and if you want to see these slides after the presentation, they're already uploaded on GitHub. So it's github.com/hacknorthwestern, I think. And all the slides from past presentations are there as well.
Shall we begin? Okay. Great crowd tonight. All right. Hey, everybody. My name is Chris. I am a senior in McCormick studying computer science. Is this a good volume for me to talk at? Yeah? Okay, cool. And yeah, so today, along with my colleague Brandon, oh my goodness. Never mind, is he even my colleague? My colleague Brandon, we will... We'll be going over the basics of Git. We'll be teaching you all how to use Git. So Git is often a confusing topic for beginning programmers to learn and get used to. And in my own experience, and I'm sure in the experience of some of my peers, it's not exactly given the best coverage in our normal classes at school or in the computer science curriculum. So, the purpose of Hack Night is to fill in those gaps, and well, that's why we're here tonight. So before I continue, I just want to emphasize the importance of you all asking questions. So a lot of the explanations that I give here may not entirely be crystal clear, and Git itself, as I just mentioned, can be very difficult to grasp at first from a conceptual standpoint. So I highly encourage all of you to raise your hands or yell at me or stop me, or as you can see, you can go to that link on the PowerPoint and ask your question there, and I will stop and attempt to answer it to the best of my ability. But yes, please, I cannot stress enough, if anything that I'm saying doesn't quite make sense, that's probably my fault, and I insist that you all ask me, and me or Brandon or Meg or somebody will definitely be able to answer for you, especially during the demo as well. Okay, so without further ado, let's get started. Sorry? Oh, the link isn't working? Classic. Okay. Well, the link is. How do we get back to the presentation here? Oh, here it is. If I present. All right, let me try it again. Sneak peek at what I'm about to say to you guys here. Oh, am I? I can't even see this. Okay. Start new. All right, how about that link? Does that link work?
Yeah. No?
No?
Oh, it might.
I'm just gonna change it to anyone. So.
You have to be signed into your Northwestern email account.
I just changed the permissions, so I don't think you have to anymore, actually. But let's confirm that. Oh yeah. Okay. Great.
No,
so
I need
somebody has.
It's working?
Is it working now? All right. Excellent. Oh man. All right. Let's get started. So a lot of there's a tendency in our industry, right, for a lot of the more experienced professionals to throw around buzzwords that not everybody in the room can understand. So I am not a professional yet, but I will try my best to make sure that we start at a baseline of no real prior knowledge about what Git actually is or how it works or anything like that. We're going to start from the beginning. So what exactly is Git? That is not Git. That is a picture of a video game controller. But it can be, but Git can be explained in some ways through a video game analogy. So let's say that you're, playing a video game, maybe Pokemon or something, and you just beat like a really tough gym leader, or you're about to face off with like the Elite Four or like some other boss battle, right? And the last thing that you'd want to do is after you die, if you go in there and your Pokemon aren't strong enough and you die, the last thing that you want to happen is for you to start all the way over to like a previous point in time than you would have liked. And so the point of that is that you kind of want to save your progress at some point, right? So it's imperative that you do so, because if you mess things up later on, then you know that there's like a good state of the game that you can go back to where you can try again. So Git is similar in that it allows you, the programmer, to essentially save the progress of your code base or your project at any given time. The main point of Git is that it exists so that you can change, break, or fix your code or make any additions to your code that you need without the fear that you will, forget whatever changes you might have made in the future that will mess it up permanently. So if you break your code, then you know that you have some save point, as we'll call it right now, where you can go back and your code will be working at that point in time, and you know that you can always go back to it to try again or try to implement some new feature. So does that analogy sort of make sense to everybody? Any questions so far? Question on the tools? No? Okay, so yeah, the video game explanation is pretty fun. But let's go ahead and formalize the definition a little bit. Git is what people call a version control system, and it allows for the programmer to track the changes that are made inside your project. It allows you to create a history of your code using these so-called save points. You can create them whenever you want, and by doing so, you are essentially creating a snapshot of your code, of your entire project at that specific point in time, and you can go back to it whenever you want. Now, to properly use Git, it is to your benefit to create these save points at like when you've reached a good stopping point in your code, like maybe after you've added a function, or after you have implemented a new feature, or maybe after you've like fixed a bug, right? It's good if you make these save points in like a systematic way, like so that you know exactly what kind of work you did at a high level between commits, so that you know how far you might want to jump back, or like what changes actually happened in a particular commit. One other thing that Git allows people to do, which Brandon will go much deeper into, is that it allows you to work with other people to edit the same code base in the same project without, or well, I wouldn't say it's completely without, but without as much fear in like overwriting each other's changes, or not being able to keep your project in sync across everybody's computers. Git itself is not a complete solution for this, but something like GitHub will allow you to achieve this functionality. And I will go over that distinction between Git and GitHub like almost immediately after this slide. But just basically know for now that Git is a great tool for collaboration, and it's one way for a lot of developers to contribute their code to a single code base with minimal problems is the ideal situation. Any questions so far? Okay. So what is exactly the takeaway here? What I'm trying to say is that Git makes it very difficult for you as the programmer to completely trash your code base and render it into a permanent state of brokenness, and to a point where like you don't know how to get back to a working how do I say it? Like state of your code in the past, right? So using Git is to your advantage, you know, as a programmer once you are more familiar with it. So I mentioned that collaboration is great with Git, but let's talk about, you know, how to use Git while you're alone. Oh, by the way, these slides were created by not me, by somebody named Elena Kafkes, and she's awesome. So just a quick shout out for that. Yes, some terminology here. Okay, Git, like the word Git. I already kind of explained what Git was, but a lot of people like to conflate Git and GitHub. So let's go ahead and explore that difference right now, very briefly. Git, as I mentioned before, is a version control system. GitHub is a place where it's a website where you can upload projects that use Git. So like, do you see like the difference there? You don't need to use GitHub to use Git. And so like a lot of the terminology and the commands that I'll be going over will apply independently to Git, and you don't actually need to use GitHub to take advantage of a lot of its benefits. There are a couple of terms later on that are pretty exclusive to GitHub, which Brandon will go over, things like forks or pull requests, but he will make those very clear when we actually get there. Okay, so that's the difference between Git and GitHub. Git is the thing that we're teaching you today. GitHub we're also teaching you, but Git is the tool, and GitHub is just a place to hold projects that use that tool. Make sense? Okay, the repository. So the repository, a lot of people like to abbreviate this when they're speaking or, you know, in text as repo. A repo is where the actual history of this code base is stored. Typically, there's like a one-to-one matching of repositories to projects, but it's not completely unheard of for a Git repository to hold the history of multiple projects. So where exactly is this repository, you might be wondering. So the repository is stored alongside the files that make up your project. When you create, or like when you start using Git for the first time, what happens is this tool creates a hidden folder called .git. And that resides inside the same folder of where all of your project files are. And within that folder is where the Git repository is, and that is where all of the files are being stored, and not where all the files are being stored. That is where the history and all the snapshots and all the save points of your code is being stored and handled. A commit is a formalized term for what I've been referring to as save points. Okay, so the commit is basically a saved version of your code at any particular point in time. They are organized by commit messages, which the programmer uses to give others and themselves a high-level overview of what actually happened during the time from when that commit was made to the previous commit. And a commit is generally consists of, like, you can think of it once again as like a snapshot of the code base at some period of time. The last commit holds essentially the most recent versions of all the files up to that point in the code base. Local versus remote. This is a pretty important distinction. I'm going to go over it a little bit. This distinction applies a lot to collaboration. The difference, I'm just going to say it right now, like a local repository refers to the Git repository that is stored physically on your machine, like on your hard drive. A remote repository is something that is stored in the cloud online somewhere, like on GitHub. And the local repository encapsulates the entire history of the code base that you've created, while a remote repository allows for multiple people to merge essentially the changes that they've made in their local repositories onto the remote repository. So like storing it online is an easy way once again, to collaborate inside the same Git repository, and as a result, the same project. Maybe this will become a little more clear, or a little clearer when Brandon gets to the GitHub collaboration part. But just real quickly, right? The local repository is what's on your computer, and it's what we're going to be messing with, basically, like the entire time that I'm going to be talking with you all. So, right. I will try to follow up with definitions of these terms as we move along. But yeah, does anybody have any questions about the definitions of these terms? Once again, I think it will become a little more clear, like a little clearer as we move on, but just right now, anything? Okay. Well, then let's talk about Git commands then, while you're on your local machine. So these commands are things that you will run in a command line interface. How many of you all here have used like the terminal or like the command prompt on Windows or Mac or Unix or Linux, anything like that? Okay, most of us here. If you haven't, that's okay. We're going to just do some very, very simple things on the command line, and I will show you exactly what I'm talking about. But basically, these commands are going to be run within this so-called command line interface, and that's where you are going to be using Git. So let's just go ahead and jump right into these commands and exactly what they do. The first command that you're going to run that pertains to Git is always going to be git init. And init stands for initialize, but what exactly does it do? Well, what it basically does is it takes the current directory or the current folder that you're in, hopefully where all of your project files are and everything, and it will begin to track all of the local changes that happen in that repository. It will essentially create a Git repository for your project. And that gives you the power to create version control based history for all of the contents in that folder. So after initializing a Git repository, you will then begin to track the changes that you make inside that folder. And the changes that you make can easily be visualized with the git status command. This is probably going to be one of the most frequent commands that you will run on the command line using Git. So what git status does, it allows you to visualize the state of all the files that you're tracking inside your project. So some of these statuses include something being staged for commit, which basically means that the file was marked by the programmer or by you to be put inside this next save point or this next commit of the code base. Unstaged but modified means that Git was previously tracking this file inside your project, and it notices that you've changed it since your last save point. So it's going to tell you that that file has been modified since the last commit. And you also have unmodified, which is any files that Git is currently tracking that lines up with the most recent version of your last save point, your last commit. And then finally, you have untracked, which is every file that Git has found inside your project folder but hasn't yet been told to begin tracking them. So I think one of the more confusing things to understand here is the distinction between staged for commit and unstaged but modified. There's something called a staging area with Git, and what that does is it allows you to see exactly what files you are going to include inside your next commit. And basically, the reason why you would want this staging area is because sometimes you are going to edit a lot of files and you might not want to save the state of every single one of those files. So there has to be some way to differentiate between the files that you've modified but don't want to add in this next save point and files that you have modified and you do want to add. So the ones that you do want to add to the next save point, you're going to move them into the staging area. Concern yourselves with as far as files go inside a Git repository or inside a project. Is that at least somewhat clear? So there are like 4 main statuses you want to. What do I mean by visualizing a state? Yeah, okay, so, right. The question is, let me see if I can pull that up. Look at that. What do you mean by, yeah, crazy, right? What do you mean by visualizing a state? Well, what I mean is, when you run this command, Git is going to display some sort of output for you. And what that output is going to do is it's going to basically group the files into these 4 possible statuses that I had shown you, or that I had talked about earlier, where it's staged for commit, unstaged but modified, unmodified, and untracked. There are more statuses as well, like if you delete a file or something like that. But generally, these are the 4 statuses that you're going to have to get used to seeing. And when I say visualize the state, I simply mean it prints out what all the files are that are staged for commit. It prints out all the files that are unstaged but modified. It prints out, it doesn't print out the files themselves, it prints out the names of the files. It prints out the names of the files that have been that have been untracked, prints out the names of all the files that have been unstaged but modified, prints out the names of the files that have been staged for commit, and for any of the files that it's already tracking that have been unmodified, it won't print anything out for them because that would kind of be redundant. And it would fill up the screen like a whole bunch. But those 3 statuses, it basically lets you tell, what status each file is in that you could possibly include in the next commit. Let me drink some water real quick. Okay. All right. So, right. I mentioned that you have these untracked files, or you have these files that you haven't yet staged, but you have modified them since the last commit. So now you want to maybe save some of these files and store them in the next commit, right? Like that's like a fair thing that you might want to do. So how exactly do you do that? Well, you're going to use this command called git add, and then this argument here, which is the file name, which is the name of the, the name of the file that you want to add to include in your next commit, your next save point, your next snapshot, whatever you want to call it. So what this does is it stages files. So it takes the files and it adds them into the staging area. It adds any of them as long as they were previously untracked or they were unstaged but modified. There's this really good flowchart that I found. I don't know. I could probably include it somewhere in the slides later, but I think it does a really good job of illustrating like the workflow of how a file moves between these 4 statuses depending on the commands that you run with Git. Can you remind me to include that or something at the end? Yeah, I don't know. I didn't really put that image in there, but I think it'll be really useful. So definitely check. Make sure you all check the Facebook event after this because I'll include a link to that image. But essentially the git add command takes any files that you have changed since the last commit and it basically prepares it. It stages it so that when the next time you commit, you know that those files and the changes made in those files are going to be added into that commit. So there are basically 2 major ways that you as the programmer should start out using git add. One is git add file name, right? So that's the most basic version of git add. And what that does is it takes in the name of one individual file and it stages it for the next commit. You can also, to shorten things, use the -a argument, the capital A. And what that does is it stages every file that is either untracked or unstaged but modified. Any questions about that? Okay, so let's say that you have staged a few files now. So we have a project, we made some changes, Git has recognized that these are either untracked files or they're modified files, and we have run git add on all of those files, so now they are in the staging area. Well, let's go ahead and commit that. So this is how you save the snapshot. This is how you make a commit. It's git commit is the main command. And then almost always you want to pass in this little -m argument that allows you to add a message to your commit. This is very important, and it's something that is kind of a joke to a lot of people too, but making a coherent message for your Git commits is the easiest way for you to see or to get a high-level understanding of all the changes that you made from the previous commit to that commit. So it's definitely, an example of a commit would be if I, made some, if I added, a new like Python file or something, then and I, and it has some functionality like allows you to make payments for my app, then like in the commit message I could be like add payment.py or something that makes that like initializes this payment API that we're using or something. Basically, the idea is just of these messages is to make sure that your code stays organized and that you are able to understand like what changes you had made in each of these commits. So that's what the -m is used for. I mean, if you don't use the -m argument, it's going to prompt you to include some commit message anyway. But like this is just the easy, like really shorthand way of doing it in a way that a lot of people end up including commit messages. Like that's like how it's usually done. So does anybody have questions about this commit command here? As you can tell, by the way, every command starts with git. So like that's like how you basically are going to run git in the command line that we're going to show you in a little bit.
Just jump into the terminal.
You want to see right now?
Yeah.
Okay. Yeah. You know what? Enough talk. Let's do a demo. All right. So you guys can still hear me, okay? Right? Is that cool? Yeah. All right. We're going to jump into the terminal or a command line interface. We're going to have people, I don't know who's around here, Lily and Meg over here and Brandon as well. If you have any questions at all during this demo, I will stop for you so that we're all on the same page here. So hopefully it will all make sense. But the first thing that we're going to do, so yeah, just like if you have questions or anything, just please raise your hand. And Brandon, Meg, or Lily, I don't know if Wesley's around here. Is he? No, probably not. But they will be open to helping you.
Also, really quick, there's problems with the Google Slides question and answers. So if you have questions, just raise your hand. Thanks.
All right. So the first thing that I want you all to do is I want you all to open up a terminal. And so how you do that is on the Mac. If you're using a MacBook, what you're going to do is you're going to hold down the command button, press space, and then type in terminal, and then hit enter. So I already have one open up here, but yeah, that's what you would do. If you're on Windows, what you can do, I'm pretty sure, is if you click the start button, if they still have those nowadays, they still have start buttons in Windows 10, right? Click the start button and then search for, is it, yeah, CMD. I'm not sure if you have to use PowerShell for this. You probably don't, but yeah, so yeah, search CMD and press enter. Come on, man, we're live streaming here. Okay. Okay, so, all right, so has everybody done that? If there's anybody having trouble with it, please raise your hand. You should see like some sort of like blank box appear. It can be white. I think on Windows it's like by default black.
Have we gone over how to install it if you don't have it installed? Everyone should have it installed in some cases.
Yeah, if they haven't yet. Windows like command prompt doesn't have.
Right. Okay.
Does anyone not have Git installed yet? Great.
Yeah. So hopefully, when you're here, or if you're on the live stream, there are a few prerequisites. Among them being like a basic understanding of the command line interface. But honestly, like since we're already here, we're just gonna go ahead and try to start from scratch if possible. But other than that, you should definitely have Git installed. You should have like run through the instructions. For your appropriate platform or for your appropriate operating system. So I'm going to assume that you all have, in fact, installed Git. If that's not true, then please go to the Facebook event and quickly do that. Is there anybody in this room that has not done that part? Right? Okay. Yeah. Okay. Cool. So, all right. So we all have the terminal open. Okay. What we're going to do now is let me first explain the command line, I guess. In like a really simple way of looking at this command line is just imagine that you have, if you're on a Mac, imagine that you have a Finder window open. Or if you're on the PC, imagine that you have like Windows Explorer open, right? So you can see like a whole bunch of your files and your folders and applications that you can double click to open. Essentially, what you've done by opening up a terminal is you have opened up a Finder window or a Windows Explorer window, but like you don't see any icons or a list of any items or anything like that. And you start out in a particular folder called the root directory. To see, I guess it doesn't really matter like where the root directory is located right now, but if you want to see the files right now inside your terminal, then what you can do is just type the letters ls and then press enter, and you can see a list of like all the folders that you currently have inside wherever you happen to land on your machine. On Windows, this might not be recognized as a command, so you can use dir instead. So just type dir and press enter. So then you should be able to see like the names of things. These are either folders or files that are located where you are currently inside your machine, like on your hard drive. So from here, I guess, we can move into one of these folders. So what I'm going to do is so like this is the equivalent of you like finding a folder in Windows Explorer and like double clicking it, okay? Like this is the equivalent of like going into a folder doing that way. What instead you do on the command line, you don't have a mouse, right? So you can't double click anything. What you do instead is you have the command cd, and then you want to type in the name of a folder. So in my case, I want to go into my desktop. So I'm going to go ahead and cd into desktop. I don't know exactly where the a Windows user will start out when they open up their command prompt, but basically what I'm trying to do is I'm trying to find you all like a good place to create a new folder so we can like actually get to the Git part. I don't really necessarily want to do that in the root directory just because I feel like that's like the wrong way to go about doing things. So for Windows, I don't know, I'm like kind of blind here, but hopefully, I don't know, like, sorry? Oh, okay, great. So if you're in the user directory, then you probably have a desktop folder. Is that possible? Okay, yeah. So just just type in cd space desktop and push enter. So what this is now you're like inside the desktop folder. And what the desktop folder is, it's basically all the files that you have on your desktop. So like on the place where like your wallpaper is and everything, all the icons on there. That should be all of the different things that you have there. So if I type in an ls again to list all the content of this file, hopefully there's nothing weird on there. No, it doesn't look like it. Good. So yeah, so this is a list of all the files and folders that are on my desktop. And to prove it to you, let me, can I do this? No, it doesn't look like I can because I'm on a different monitor. But anyway, on my main MacBook screen, like on my main MacBook background, if you were to go to my desktop, you would see that these are all the files and folders that I have on there, okay? So I'm going to go ahead and run clear. What this does is it basically like clears the output so that I can start from the top. But yeah, so we should be in the desktop folder. Is everybody good with that? Has everybody CD'd into their desktop? Is there anybody that's having trouble? Please do raise your hand because it only gets tougher from here. Everything cool? Okay. So now what we're going to do is the equivalent of right-clicking and pressing and creating a new folder. So like if you were in Windows Explorer, right, to do that you could right-click wherever you were in the Explorer and push new folder. You could probably do the same thing on Finder as well. The equivalent to do that on the command line is mkdir. mkdir space, and then this is the name of your folder, right? So this argument is going to be whatever you want to call your new project. I'm going to call it intro-git, and I'm going to press enter. And now if I ls again, you will see inside here that I have, where'd my mouse go? Oh, right here. Yeah, you can see intro-git is among the list of things that I have on my desktop. Is that clear for everybody? If you're wondering what mkdir stands for, it stands for make directory. Directory is another name for a folder. CD, which is the thing that we're using to move into a folder, that's change directory. That's what that stands for. Does anybody have any questions, issues? Okay, great, awesome. Wow, this is wonderful. All right, so now we're going to go ahead and change directory and go into this empty folder that we've just made. So what did I call it? Intro-git, yeah. So cd intro-git. and push enter, and we are in there. And if I ls, you can see there's like nothing in there, right? Because it's just an empty folder. Make sense? All right, so now this is a new project, right? So I'm a dev. Let me go ahead and make a new Python file. How about that? The first thing that I'm going to do is all right. I'm going to basically run a command that is going to create a Python file containing one line. And that one line is just going to be a print statement, okay? It's just going to print something out. It's like hello world, basically, okay? So that command may not entirely make sense to you, but I will try to go over it. If you're interested in knowing exactly what it does, then we can stop and investigate it. But basically what you're going to do is you're going to run a command echo. You're going to type echo, and then you're going to start with one pair of double quotes, and then you're going to write our one line of Python code. Now, what exactly is this Python code going to be? Well, it's a print statement, I said, so it's just print hello hacknight. Make sure that you're using single quotes inside these double quotes here. Hello hacknight, right? Print hello hacknight. Close off your double quotes, like I did, and then space, greater than sign, main.py. Sorry, I need to make sure I'm actually doing this. Okay, yes, I am. Okay, and then press enter. And if we ls, you can see there is a new file here called main.py. So what exactly is this file? It's a Python file. For those of you who are not familiar with Python, it's like the equivalent of a .cpp file for like C++. If you all have started taking EEX 211, or if you haven't, then in EEX 111, I don't know what a dot for a racket file. It's probably like .rkt or something like that. This is the equivalent of like that for Python. Okay? So what exactly does this do? Well, once again, I had, what's inside this file, right? I could run this command, cat main.py, and it will just print out what I had put into this file. And as you can see, it's print hello, hacknight. And you may not have Python installed, but just to prove you that this is a fully working program, I can run this command, python main.py, and you can see it does exactly what I said it would do, is it prints out hello, hacknight. Does everybody follow so far? Does anybody have any questions? Now I'm pretty sure that echo command that I did works on both Windows and Mac, because there are a couple different ways you can do this, but when me and Brandon were planning this, it was we had to find a way to easily do it on both operating systems. But yeah, so now you should have a Python file inside your directory. Okay, now here's the fun stuff with Git, okay? So we've just made this new file, all right? Let's go ahead and initialize, in our project, let's go ahead and initialize a new repository in our file. So does anybody know what command we're supposed to run here? Does anybody remember? Sorry? Git initialize. Yes, that's basically right. But initialize can be written shorthand, and it needs to be written shorthand as git init. Okay, so we're going to run git init. And then the thing that we'll see here is it initialized an empty Git repository and this is the path from my root directory to where I am currently. Does everybody see that message? Initialized empty Git repository? Does anybody see something that isn't that message? Okay, cool. So yeah, now we have a Git repository in here, and to prove it to you, I can run ls and then pass in this optional argument -a. And what that does is it shows all the hidden files and folders inside this intro Git folder that I've created. And you can see that there is a .git folder in there. That tells us that is where our Git repository is. And when you run a Git command, it searches for that .git folder and it makes sure that it has one before it does anything. So that's how we know that our project now uses Git, is the presence of this .git folder. Cool? Okay, so now we're going to run the second command that we went over, which is git status. And what git status is going to do is it's going to visualize the status of our files. So if you just run git space status, you can see. Ignore the very first line for now. But what I want you to focus on is where it says untracked files. So as I said before, there are a lot of different statuses that files can take. Among those being untracked files. Every file that you initially create inside this project, Git will not by default track these changes. So you need to add it inside a commit as soon as possible if you want to begin tracking the changes in your file. So as you can see, Git as a tool, it also tells you, that you can use git add, which is a command that I had just gone over, to actually include main.py inside our next commit. So currently main.py is untracked. If I run git add main.py, exactly like that, and press enter, and then if I run git status once again, you will see that the status of this file has changed. It is no longer untracked. It is changes to be committed. And what that means is that main.py is now inside what I said was the staging area. And so that means main.py, on your next commit, the changes made to main.py, or in this case, the fact that we created main.py, that change is going to be reflected inside the next save point that we make, inside the next snapshot of our project. Does everybody have questions? Is everybody on the same page here? Okay, so we have a new file in our staging area, and let's go ahead and commit it. Let's make a save point. So I'm going to run git space commit space -m, and as I mentioned before, the -m argument allows you to specify a commit message directly on the command line. So in this case, I will make that commit message say add main.py. So this will tell me when I look at this commit in a later period of time that, this is the commit where I added main.py. It's like pretty self-explanatory here. I mean, it's, it'll get a little grainier, right, as your commits maybe become larger. It's probably a good idea if you try to keep your commits like in small bite-sized chunks, just for that reason too. So it's easier to undo like smaller commits than it is to undo bigger ones. But that's beside the point. Basically, yeah. So this is a commit message. So all I have to do is push enter, and we will see, what does it say? Yeah, what this essentially means is that in the commit, it will tell you, right, like how many files were changed in this commit since the last one, which we didn't have a last commit. So for this very first commit, we have one file changed, one insertion, and that insertion stands for how many lines were inserted, okay? So I added one new line. That's why it says one insertion. And you don't really have to worry about the create mode line at all. That just says, it basically just says we're adding main.py to the Git repository for the first time. Is everybody clear? We good with that? And then just for kicks, if we run git status again, you will see that there's nothing to commit because all of our files inside our Git repository are up to date with the files inside our project because we never made any new changes to main.py, right? So there's nothing to commit, and the status of main.py can be considered unmodified. Or, yeah, right, unmodified. Tracked and unmodified because we're now tracking main.py as well. Sound good? Excellent. Well, for those of you who have never used Git before, congratulations, you have made your first commit. I'm happy to be here with you for this moment. Yeah, thanks, Brandon. So let's get back to the slide. Okay? Here we go. All right, we're at git commit. We just have a couple more commands I want to go through, and then Brandon's going to take this. This is long, man. Okay. All right, git log. Okay. We were saying, Git is a really tough concept to grasp at first. So seriously, if you guys have questions, I'm not hearing enough, but like if you have anything at all, just please stop me. I'm here to help you all. I want to. It's what I do. So git log. Git log is another command that allows you to see the history of your code, right? Like you made a commit just then, right? But like how do you know that commit actually happened, and like how can you see any other of the other commits that you've made, right? Git log allows you to do that. And git log also serves as an important way for you to be able to undo or to revert back to previous committed states of your project. Git log is very useful for visualizing your code's history. And in the history, each commit is listed individually, and it includes the commit message, the timestamp, meaning when you had made that commit, and also this like hash value that uniquely identifies the commit. And we're going to use that hash value when we want to undo the changes that we've made in a previous commit. To show you what I mean, I'm going to flip back to my terminal. Hopefully you guys still have that open. Hopefully you didn't close it. And I'm going to run the git log command. So git space log. I'm going to press enter. As you can see, we have one commit in our Git repository. And that really long thing you see at the top there is, of course, the hash value. It's a long hexadecimal number that uniquely identifies this commit. It tells me the author who made the commit. It was me, yours truly. Tells you the timestamp as well when I made the commit. Seems right. And it tells me the commit message that I had included, which of course I said was add main.py. Does everybody see this inside their git log when they run git log inside that directory? Does anybody not see it? Do you see it? Yes.
Given saying that, like asking, tell us who you are, or something like that. Like,
Oh, they ask who you are?
they ask it for an author.
Oh, that's interesting because it's not they're not trying to connect to a remote repository, right?
Yeah, I did, but like it didn't work. Okay, I will figure it out.
Skip it for now? But like it's going to be an issue like later on, isn't it?
I'll talk about it. Well, the problem is authentication, right? Like they
Right.
I'm gonna go over it.
Okay. Yeah. So that is probably an issue with like. It's probably asking you for like, well, like it's asking for your name or like email and stuff, right? Okay. Yeah. Brandon was going to cover that in a future step, but if it's asking you to do it, then try to follow up with it right now, I guess. Wait up on him. Is anybody else having this problem? Yeah? I'll just wait up for him. It's fine.
I'm probably gonna omit my slides.
What? You're probably gonna like,
Omit my slides.
yeah.
I'm just gonna go.
This is long.
Yeah. Yeah.
Honestly, like we should probably not talk about that. I feel like.
Yeah. Well, I'm just gonna.
Anyone else having issues?
Quick question. Can you change the message that you that is a commit so you commit?
Yes, you
That's more. We can talk about it later.
Huh? He just left. He's on. He's lost. He took me. We're good? Yeah? Everybody cool? For those of you watching the live stream, sorry. And also, if you're running into the same problem as other people where like there are like a couple of lines in the error message that say something like git config and then -user.email and user.name, for those lines, what you're going to want to do is literally like copy and paste each of those lines individually into your command line and run them with your actual email that you use to create your GitHub account, and then your full name for the other line where it asks you for user.name. So that's how you're going to resolve this issue, is one at a time, run each of those lines on the command line, fill it in with like real information, and run it, and you should be able to commit at that point and see this in the log file. And also on the live stream, I don't know if you, oh right, no, I forgot that the Google Slides question doesn't work anymore. Never mind. Okay. Is anybody else here having issues? Are we all on the same page? Can we all see Git log? We're good? All right, wonderful. I'm gonna go over okay. I'm gonna go over two more commands with you all. Git diff, real quickly. Git diff allows you to like zone in on the difference between the changes that you've made in your project right now and the last commit that you had made. So to illustrate this, I am going to go into, I am going to go into my command line once again, and I'm going to go ahead and add a new line to my Python file. So I'm going to do echo print goodbye hack night. No, I can't use these double quotes, man. That's not right. Goodbye works. And once again, I will do this greater than main.py. So if we cat main.py, we will see that the line has changed from print hello hack night to print goodbye, right? And if I run this as a program, as you can see, we confirm that it does in fact work. Has everybody done that? Does that make sense? What we did, we basically just changed that line that we had in our Python file to print something different. If we run our git status again, you will see that that main.py has now been modified since the last commit. Okay? And to see exactly how this file has been changed is where our new command comes in. Git space diff. If I run git space diff, what it does is it allows the coder to see what changes they made to the files, and it shows line by line the changes that you made. So to demystify this for you real quick, the red here means that we deleted this line, and the green here means that we added a line. So this is a very simple diff between our most recent commit and the changes that we've made to the project since that commit. Does everybody see that? Does it make sense? You don't see that? What does it say when you run git diff? Just goes to the next line without saying anything.
Do you change anything?
What happens when you type git status and then push enter? Okay, sure, no problem. Does anybody else have questions, problems with this? Okay. Oh, people.
Assuming the position.
Maybe I should even bother with the git revert.
Yeah, that's fine.
No,
Yeah, just
fine. Okay.
can I move on
Yeah.
with this?
Sure.
Oh, you're gonna.
Well, I mean, I'm gonna like transition you, right? At least. I don't know.
Thanks.
I thought maybe.
Thanks, man.
Yeah, you're welcome. You're welcome, Brandon. For all I do, you. Okay. Is everything good? Okay, yeah, so, right, those are really all the basic commands that you need to know to really use Git at this point. You're probably wondering, how do you actually like undo changes or roll back commits? There are a couple of different ways to do that. I will post on the Facebook event a link to help you guys better decide, because there are like a bunch of different ways that you can do it. You can use a command called git revert, or if you're feeling dangerous, you can use git reset. Yeah, there are a couple of different ways. So I will also attach a link for that, and I will also give you all the link that has an image that better visualizes the different statuses that a file moves into and out of as you work through Git. So at this point, I'm going to go ahead and pass it on to Brandon, who will talk more about GitHub and collaboration.
What's up, guys? Y'all want to hear a joke? A Git joke? What's the problem with Git jokes? Anyone? That's a good one. That's a good one. I didn't think of that one. Honestly. Everyone has their own version. No? Okay, tough crowd. It's fine. It's really fine.
Dang, wow, crazy.
How do I mirror this? Am I?
Is it not working?
I just tell jokes all night.
Ah, there you go. I think it's just, here, hold on, just stop touching it, man.
Okay. Okay. So, okay, who here has, does everyone have a GitHub account?
Dude, you're fucking... What?
Oh, no, okay, I'm just checking, Okay, yeah. So he went over local repositories, and that's cool and all because you get to like save a bunch of, like a huge history of your commits locally. That's fine, that's all well and good. But if you actually want to collaborate with others, you need to set up a remote repository via GitHub, which is a service for hosting remote projects of this kind. So we're gonna go to GitHub, okay, yeah. We're gonna go to your page, go to your repositories, and we're gonna create new. We're gonna create a new project. So I'm just gonna name this project whatever. It's gonna be Professors Who Don't Hate Me.
Good if you turn Flux off.
Oh shit, right. I mean, oh darn. Yeah, so we're gonna create this remote repository. As you see, we're gonna click create repository. And this is gonna give you a bunch of instructions. This is all really verbose, and it gives you different instructions for different use cases. What we really wanna pay attention to is these lines right here. So these are basically giving you commands to do in your local terminal to actually link up your local repository to your remote repository on GitHub. So what this is adding your origin, and origin in this case you could think of it as your remote repository's URL. And then here it says to push to your repository's master, which we'll get into when we talk about branching. But yeah, I'm gonna go back to, I'm gonna copy this, copy the first command, git remote, add origin, and then your URL. And then I'm going to go to my command line. I don't know if y'all can see this. Should I increase? Computer, increase. Okay. Okay, can you guys see that pretty well?
Maybe a little more.
Jesus Christ. Yeah? Cool. So I'm in like an empty repository right now. Right now, Chris showed you a little bit like of the command line basics. I'm gonna create just a local directory, and I'm gonna do that. And it doesn't have to be the same name or the exact same name as your remote repository name, just to clear that up. So I'm just gonna call it something. And then I'm gonna change directories and go into it. And first off, I wanna initialize the repository like Chris went over. And so that says, oh, initialize an empty Git repository. That's all well and good. Now I'm going to copy and paste this command, which adds the remote origin, which is the remote URL of your Git repository, your GitHub repository. So it's basically saying, oh, this local repository, when you push or upload code or fetch code remotely, it's going to look for this URL and say, this is where it needs to go. Does that make sense? Sure. Okay. Okay. So after you do the command, nothing's going to happen, and that's fine. Like, so to check if it actually worked is you type git remote -v. And press it, and then you should see 2 lines that say origin. One for fetch and one for push. So what fetch is basically says if you try to fetch or retrieve code from your remote repository, it's going to point to this remote URL, and if you push your code, it's going to upload this code to this remote URL. Does that make sense? And if this is too fast, I'm sorry. Like, for the sake of brevity, I'm just like kind of explaining things as we go on. I kind of omitted the slides, but it's fine. But yeah, that's really what we need to do. Oh.
How did you add the website there?
Yeah. So right here on your repository, it has like or push an existing repository from the command line. And that's like, yeah, that's what you need to copy and then go over to your thing.
So this information exists when you open a new laptop?
Yeah, that's when you like first like click new and create a repository. So yeah, so we're actually just gonna push something to this remote repository. So we want to create a file. I'm just going to say professors.md. I'm using Vim, which is terminal-based terminal-based editor. If you guys aren't familiar with it, I'm just adding stuff to my file. If you don't want to use Vim, that's fine. Yeah, you could use your favorite code editor to edit this file. We're just going to make some changes. So we're in professors.md, which is a markdown file, and we're just going to make a list of professors that don't hate me. So this is going to be empty. No, I'm kidding. Let's add some names. Shout out some professors. I really hope she doesn't hate me. I'm just guessing. Okay, we're just adding 2 names. And then I'm going to do WQ, which is write quit. So I'm writing the file, and I'm quitting out of the file. Make sense?
Dude, I mean, if they're not using Vim, if they're using Vim, they're already confused. If they're not, then they already know.
Maybe, should I not use Vim then?
You already used it.
Okay, it's fine. Okay, I just edited the file. You could edit the file however way you want. But if we read from the file using cat, you could see my changes are there. Are we all on the same page? Do we all know what I just did? Okay.
Raise your hand if you're confused.
Okay. 1 out of 100. That's not too bad. That's not a bad proportion right there. So because we already initialized a Git repository, I should probably wait, huh?
Yeah, probably.
That's a good question.
Try mancat and see if it says anything about it.
Let's try man. And man is like a manual.
Concatenate.
Concatenate. There you go. That doesn't make any sense to me. I'm guessing it's because you have a buffer, right?
Well, like I think you can give multiple arguments to cat, and what it'll do is it'll like concatenate.
Oh, okay, yeah, that makes sense. Okay, yeah, it's concatenate or cat because you could have multiple arguments, and then it all like prints them all. It concatenates all of them, or like adds to each other, and then just prints out a whole dump of information.
Can you show your path, please? Or like, are you in another directory? So in tutorial, they have like a directory something.
Yeah, they can make a directory like of whatever name, as long as they like add the remote URL, like I showed, using this command. And this would be your remote URL of the of whatever you made on GitHub.
Yeah, but for your older, like, what did you make a new directory inside your Git tutorial?
Yeah.
And then you made a new directory.
Yeah. And I initialized a Git repository within this directory, not GitHub tutorial.
I see.
Yeah, you see? Okay.
Yeah.
What's the word? Are we good with that? Should I wait a little bit? Is the pace I'm going? Okay.
Does anyone else have any questions?
Oh, you could do git -- help, and then I'll show you. Yeah, I probably should have mentioned that, but I mean, is everyone like logged into their terminal?
Well, they gotta be. Well, I mean, they have their email on there. I don't think they're logged in.
Like logged into the terminal? Oh. Just as like a checkpoint, I guess. Can everyone type this command? Git config -- global -- list, and see if user.name and user.email.
Yeah, no, they
set.
had to fill that in order to commit anything.
Okay. Well, we didn't. Oh shit. But we didn't commit to a remote.
All right, so I think it'll ask them to log
Okay.
in when they try to push.
Never mind. It's fine. Is everything good with them? Is everyone good? Okay. So we just edited the file professors, and if we do git status, you can see in our untracked files we have the file name professors, and that's really what we want to commit to our remote repository. So I want to add that to be staged for committing. So what I could do is git add professors.md, and then if I do git status again, you just see that these are changes waiting to be committed. Now we're going to commit them. Okay, so once we've added them, I'm going to do git commit, and I'm going to add a message. Added some professors who don't hate me. So that's going to be a message. I'm going to commit it, and you see it's a root commit to our master branch. You can see that one file was changed was professors, which is the markdown file, and we added 2 lines. And now we're going to go over a command that we didn't previously go over, which is git push. So what git push is basically it updates changes from a local repository and uploads them to a remote repository. And this is based on what origin you really give it. So recall that when we do git remote v, this is where your local repository is pointing to. So when we push or use git push, this is where your changes are going to be uploaded. Okay, so this is the command I'm doing. It's called git push origin master. So origin is what I just referred to, which is a pointer to your remote URL on GitHub. And master, you could think of it as the master branch, which is the branch we're on by default for your local repository. So we're basically saying, look at this master branch, point to your remote URL, and upload the code to the master branch of your remote repository. Does that make sense? If not, it'll make sense. So I'm going to type in my credentials. Cool. So it counted up the objects and it wrote to our remote repository, and it says to this. We can see it's the same URL as when we do git remote -v. And if we go into our remote repository, which previously didn't have any content in it, We can refresh it. And then now you have a commit. It says one commit. It says added some professors who don't hate me, and we have the new file from our local repository. Does that make sense? Cool. What's up? Said you need to fetch first. Do you want to help? She might have pushed changes already.
Really?
I don't know. We gotta. Wait, should I go on? Lily, should I go on? Or should I just wait? Yeah. Okay, so I'm gonna go on. That was the first example. We're gonna go to a more complicated example. I previously made, so this example is gonna be all about branching and like pushing to or cloning an existing repository, and we'll see what that is in a second. So I previously made a remote repository on GitHub called Things Millennials Like, and then I'm just gonna push a list of things millennials like. So another way we could connect from a local repository to a remote repository is something called git clone. So in our previous example, we actually created a directory, initialized that directory, and actually manually linked the local directory to our remote repository, right? So what this is gonna do is it's gonna do a lot of the work for us. So in GitHub tutorial, after I copied this link in quick setup, this is just a link to the repository. I'm going to type git clone and then the repository URL. And so now when I ls, I have like a local repository that's an exact copy of the remote repository. And what's interesting, if I change directories into it, if I do git remote v, the thing that we previously had to manually do when linking the local repository to the remote repository, it already did for us. So it automatically has a pointer to the remote repository. So that's really handy. I know right now it's kind of trivial because I really didn't have any content in our remote repository yet. But if you do have like a lot of content, so let's just say like a company posts a project that they've been working on for years and they have a lot of code up there, using git clone is probably a good way to like get all that and copy that to your local machine. Okay, so we kind of understand that. So what I'm gonna do is go over the concept of git pull. So git pull is basically retrieving changes or commit objects from a remote repository and saving them to your local repository. So we're literally like pulling changes from the remote URL. So we could like demo that here. Right now, I'm gonna create a README. If anyone doesn't know what a README is, a README is basically like default instructions for a project, just saying what the project is. Yeah, so we could automatically generate a README by, let me go back again, by clicking this. if you could see it. Include a README. I'm going to click that link. And it's just going to auto-generate a new README right now. And then we could click commit a new file, and it's going to make that file for us. So I'm going to click commit. So when I click commit, it adds a README, and it also adds a commit, which was to create a README. So really, we run into a problem. Like, the remote repository has a commit that the local repository doesn't have. So we're just like, oh shoot, we gotta like synchronize the local remote repositories. So a thing we could do is git pull. So when I type git pull, it really does two things. First, it fetches, so it determines all the new commits that exist in the remote repository that doesn't exist in the local repository. And second, it merges the history of local repositories that we already had with its remote counterpart. Does that make sense? So when we ls right here, we have the README that we made in the remote repository. Does everyone see what we did? Anyone have questions? If I'm going too fast, like let me know. Okay, cool. Now we're going to talk about branches. Branches are cool and very useful, especially if you're working with other people. Branches are cool because it lets you go into, okay, let's just say you have a marker? Oh my god. Okay. So what Git is, or what Git projects are, it's basically a tree. It's a tree of commits. And that's how Git really keeps track of your history of commits, or history of changes that you make in your project, right? So let's just say this is your master, or your like default tree. It's just like one linear line of changes, let's just say. So what a branch does is allows you to diverge from this path, work on something, and then merge your changes back to the master or default branch. And the reason why you want to do that is because the master branch of your repository is really the source of the integrity of your code. If something messes up and your code is in production, for let's just say, like everything's really going to mess up. So having branches lets you modularize changes and lets you kind of work on different kinds of features in isolation without affecting your master branch. Is that a good explanation?
Why are you asking me? Yeah, that's great.
I mean, you just look like I wasn't explaining.
No, you just surprised me when you hit the wall.
Sorry. Okay, so we're gonna create a branch, and I'm gonna do a command called git checkout -b our branch name, and our branch name could be what's our thing? Add things. It's just a branch name. Add things. So to break this down, what it's doing first is it's going to create a branch called add things, and it's going to run a command called git checkout for add things, with add things as an argument. So what git checkout does is after the branch is created, it's going to switch from your master branch, which is here. It kind of denotes what I'm highlighting here, denotes what branch you're on. So once we do catch...
Yes. Question.
So this is done in the local repo?
Yeah, this is all local.
Okay.
Anything in my terminal is local. So when I run this changed, or this, what was previously master is now add things. So when I do git branch, which displays all your branches in your local repository, you're going to see my master and add things with an asterisk next to it, which means that's the one I'm currently on. Okay, so an overview is I'm going to do some work in this branch, and then I'm going to commit the branch, and then I'm going to merge it back to master. So that's the basic overview of what we're going to do in this example. Does anyone have any questions about that? Cool. Okay. So I am going to add. I'm literally gonna create a file called things. These are not realistic examples, but you know, for the sake of brevity, I'm gonna write some things that like millennials like. So I'm gonna do pogs, Twitter, socialism, the nene. Yeah, the whip. And then I'm gonna. Ooh,
It doesn't even like you.
it doesn't like any. Oh, tough crowd. Don't like the whip. Okay, it's fine. And I'm gonna save my changes to this file. So when I print out my file things, you're gonna have all the contents there. Yeah. So I want to add this file. So if I do git status, you can see that it's untracked. Moving a little faster now, we could do git add things.md, or the markdown file, and then do it again, and it's waiting to be committed. So I'm going to commit this with a message, add all the things. And then once I commit it, I want to push this to the remote counterpart of this branch. So when I push it, as you'll see, what it's going to do is create a branch called add things in the remote repository and copy the contents from here and upload it to that branch. Does that make sense? Cool. Okay. Git push origin, which is the remote URL, and then what was my things? Okay, add things. It's gonna prompt me for my username, password. Okay, cool. So it said new branch, and then add things, which is our local branch, and then this means like this is the first add things you see here refers to our branch in our local repository, and the second refers to the newly created branch, which was in our remote repository. And there are things like you don't have to have the same names. There is ways to work around it. This is kind of out of the scope of this example, but for the sake of this, just trust me on this. So we could go back to github.com, and you could see right here, it says your recently pushed branches, and it's add things. So when we go to this, we could see that this branch has things.md, and it has all the contents that I put in. Okay, so how if I want to merge? How if I want to merge all the work I did in the branch to the master branch of the repository? Well, I could do it as follows. I could do git checkout master, which is, again, just switching branches to your master branch. You can see how that changed again right here, and we do git branch. And now I'm on master. And then I could do a, oh my god, Jesus Christ. Okay, I could do a command called git merge. And what git merge does again, it merges the history of your local commits with the history of commits from its remote counterpart. So if we do git merge with origin, add things, it will merge the branch from your local branch, add things, into your local master branch. So you're probably wondering why it says fast forward right here. And that's a good question. And it really comes back to my tree example. The reason it's called fast forward is that the master branch doesn't have any changes that the branch you're merging into it doesn't have. Fuck, okay. Let me clear it up. Okay, here. So in our original node, let's say this is a node in a tree, which is our master node. And then the only change it had was the README that we had in our remote repository, but we pulled it into our like local master branch, right? And then we created a branch called add things, so a branch doc here. And that copied all the contents from the master branch to the add things branch. So add things doesn't really have anything that, okay, master doesn't have anything that add things doesn't have. It's basically a copy of it, right? So now we added something called things, which is basically our content of our whole repository, right? Our things markdown file. So I'm going to add things.md. Because it only has new things, it's fast forwarding to a new version of the branch. Does that make sense? It's not the clearest terminology, but that's pretty much what it means by that. So as you can see the number of assertions, it's 5, and the number of files that changed. And then this is fine on our local repository, but the changes aren't going to be reflected on a remote repository. So we need to do something that synchronizes the local and remote repository. Can anyone say what that is? It's fine. It's a git push. Okay. So I'm going to, Jesus. Okay. Bro. Is there anything? Sorry. Okay. So I'm going to retype my username and password. And it's going to push it here. So when I go back to my repository, it's going to have 2 commits with things in here, which was previously on our other branch.
If you're trying to do this and having issues, please raise your hand.
So I kind of missed the point of git merge. What does it exactly do?
Git what?
Git merge.
Oh, git merge. So if you run git merge locally, and the argument you give it is going to be a local branch, so it basically merges the commits from that local branch into master. So this is all local, so that's why we had to do git push and push it and sync it to the remote URL.
When I add things to MD in Essence branch, it says throughout the warning says LF will be replaced by CRLF in things.md. What does that mean?
Can you check? I'm not really sure. Cool. Yeah, while they're doing that, does anyone else have any questions? Because I'm going to move on to another example. We're good? Last thing, if you want to keep your branches clean. Oh.
How often do you work local? How often, like, if you're doing projects like for like a hackathon, usually like you just go on online. Or do you use this often?
Yes, I probably 80% of the things I do with Git is in my terminal. So basically the flow of let's just say like a hackathon project, or if you have like a software engineering internship with a team, you're basically gonna all work or all have local versions of your project and work exclusively in that. And then once you go through a review process, you push it to your remote repository. Does that make sense? Yeah, okay, like I was saying, if you want to keep your local branches clean, because I merged add things, so I don't really need it anymore. So if you want to delete a branch, which is helpful, this is just basic housekeeping. You can do git branch.delete -d and then the name of your branch. And then it says delete a branch. And then when you push it, it'll delete your branch on your remote repository as well. Cool, moving on. This is gonna be a last example, so I'm gonna put you out of this misery. And this is important for, this next example is important for open source because we're gonna go over forking. And what forking is basically you have a project on GitHub that's not yours. Someone else owns that project. And you want to make edits to that code or experiment with that code without messing up their project. So how do you do that? You could do something called fork on GitHub, which makes a copy of that project and saves it under your GitHub account. And then you could clone your version of that project, work on that, and then submit what's called a pull request to the project. Now, a pull request is basically a proposal. It's a proposal of like what you're trying to do. Let's just say you're working on a feature, like, oh, I'm trying to do this feature, and it has a diff of all the changes you made in that project. Now, the actual owner of the project's gonna review it and approve it if it's like a good pull request. If he approves it, then he has the decision of whether to merge your changed code in your pull request to the master version of his project.
Do you have a new pull request for me?
Oh, no, I don't.
Oh, is that not what we're doing?
Oh, yeah, we are. Okay, no. Okay. So we're going to go through like kind of an example of how this is going to work. So I'm looking at Chris Chen's GitHub, little bucket hat.
All right, go on.
So I really want to contribute to a really revolutionary GitHub repository called Pi Hello World. So what I'm going to do is click this. I'm going to fork the repository. And so it's going to make a copy of Pi Hello World, but under my account, not Chris's. So I'm going to click this. It's going to copy. It's going to take a few seconds, but it's fine. Okay, so some things to pay attention to. If you like compare these repositories, they're going to be the same. One thing to note here is something that says this branch is even with Chris's username and master. So my master branch is basically the same thing as his master branch in his repository, meaning I didn't really make any changes or anything like that. But once I do make changes, it's going to say like, oh, this branch is like 1 or 2 commits ahead of Chris's branch. And so there you could kind of like keep track of all the commits you pushed. Cool. So I'm going to clone this repository. Okay, I'm here. Let me clear my thing. Right here, there's a handy-dandy little thing called clone or download. I'm going to copy this. Basically, it's the same thing. It gives you the remote URL. And I'm going to use clone again, because I want to work on my version of his project. So cloned it. As you can see, and I listed out, it has Pi Hello World in there. So when I cd into Pi Hello World, if I do git remote -v, you're going to see the origin points to my version of the project, which is what we want. Now let's kind of see what he has here. Let me just see his bad code here. Okay. So he has, I think, a Python file called hello, and it just basically says goodbye hack night. We're going to change that because I want to do something completely different. I'm going to say follow. I'm going to say follow my Twitter. So yeah, that's what I'm going to say. I'm going to write to it and quit. So as you can see, my changes are still here. Weak. So again, I do git status. I want to git add the file I just changed. And now it's stage 4 commit. I want to commit this. So, cool. Yeah. So now I'm just going to push it to my repository. And after I type in my credentials, you're going to see now it has 4 commits. And then it says this branch is 1 commit ahead of Chris's master branch. So that's all well and good. So let's just say I want to submit a pull request, meaning I want to have these changes and merge them with his project. So I'm going to go back to Chris's project here. And I'm going to click this button called New Pull Request. OK, so once I'm here, I'm going to click Compare Across Forks. So it's really just going to find your version of his project and then compare the differences. So I'm going to look for my version, which is Brandon Fuji, my username, /pi hello world. Cool. And it gives the OK. It's like, oh, this is able to merge. It's not going to cause any conflicts, meaning what merge conflicts are basically like contradictions in code. Basically, GitHub looks through the different versions of the code, and if it sees certain lines that contradict each other, then it throws an error and says, you need to look at these lines and fix them manually. Yeah, so like, this is my pull request. I'm going to make one. You could leave a comment if you want. And at the bottom, you could see the diff. And the red is what I deleted, and then in green is what I added. Does that make sense? So I'm going to do create pull request. And so on his repository, he's going to get a notification, and then he has a pull request to review. And then what Chris will do on his account is he could go to it and approve it or reject it and request changes to it. So if you want to actually look on your side, we can see his version of it. Nice one.
Yeah, nice things.
Nice one. Jesus Christ.
I'm just a wreck today, and as I am in all days. Oh, yeah, you guys like that wall? All right. So, what am I looking at here? All right, I'm on my GitHub. And wow, lots of forks. What? What the fork? All right, so
Stop, please. Please stop.
I'm gonna.
Okay, go.
Oh, all right. So I'm in my repository right now. Yeah, agreed. You don't have to agree. I'm right. So, pull requests. Look at that. 2 of them, fresh, straight out the oven. I think one of them actually might have been last night, so maybe not straight out the oven. This one's kind of stale. But this one over here,
Wild night.
Brandon Fuji opened a minute ago. Well, I'm going to be a good maintainer of my own project and very quickly address this surely unsatisfactory commit because I've looked at Brandon's code before and I'm pretty sure it's not that great. So I'm going to look at this. And so what's going to happen is you see that Brandon, his commit is noted as part of the pull request right here in line with his commit message. So I'm going to go ahead and go into it. I can click on this short commit hash here and see exactly what change he had made. This is essentially like doing a git diff, except on GitHub. You can see he deleted my line and added his supposedly better one. And let's say I go on his Twitter and I'm like, all right, this is pretty cool actually. It's pretty sick. This is a pretty sick Twitter. So I'm gonna be like, all right, this is pretty good. Do I have to approve this or I can just merge it, right? Yeah, so I'm gonna go ahead and just merge this. Confirm merge. And GitHub had originally confirmed that there were no merge conflicts, which Brandon explained to you, so I can go ahead and do this safely. And you can see I have merged that commit. And if I go back to my original repository, look inside here, my hello.py. Look at that. The most recent commit shows that I have, in fact, merged Brandon's change into my file, and it no longer says goodbye, Hack Night. It says follow. I cannot read on Twitter.
I mean, the significance of this is like forking and pull requests has like a huge role in like contributing to especially big projects. So that whole protocol that GitHub has set up, where you make a pull request, it goes through like a lengthy approval process. Maybe they'll request some changes. Maybe they'll request that you do like another methodology if you're implementing a feature. This has like a huge role in like the whole open source community. So in the context of Hacktoberfest, if you want to talk a little bit about it, you're going to basically use these fundamentals to contribute to projects.
Yeah, so Hacktoberfest is going to be what the focus of next Hack Night will be, and we hope that you all will make it, right?
No.
Oh, it won't? What?
Okay, so Hacktoberfest is basically like an annual thing every October that GitHub partners with something called DigitalOcean for. If you Google it, you'll just find a website for it, and basically it's pretty cool. You can, if you make 4 pull requests in the month of October, on GitHub to any public repository, so they actually help you find projects that have open source, which means like a bunch of random people contribute to this project, and then they have people who look at the pull requests. If you make 4 pull requests in the month, they'll send you like a limited edition t-shirt, and it's a different t-shirt every year, so it's kind of a cool collector's thing. And so right now, if people want to stick around and like work on open source stuff and get help from each other, that's what we're going to do. Also, there's a bunch of like tech swag here. There's a big O notation poster for people who want room decor. And then there's a bunch of shirts and pins and stickers and tote bags here if you guys want to grab stuff. And next week, we're going to be having an internship career panel. So we'll have 7 speakers, not us, that have worked at a bunch of different companies and had different experiences that you guys can hear from. So that's what will be happening next week. Does anybody have any questions about like what Chris and Brandon talked about or Hack Nights in general?
It's a question about GitHub in general. Like for big projects, like is it possible for multiple persons to accept pull requests, something like that?
Yeah, so a repository has a specific contributors, and any contributor of the repository can look at a pull request and merge that in.
But they have to be like approved to do it, right? Like it's not just like any person. Like you add
a small group can do that.
Exactly.
Mm-hmm.
Yeah. All right. Is that it?
Cool. Thanks for coming.
All right. Thanks for sticking around, guys. Sorry, it's a longer one.